So when we have a negative number, let's say negative 2 modulo 9, as we see in this example here. Negative 2 modulo 9. Well, how would one deal with this exactly? Well, an important thing to keep in mind in modular arithmetic is that basically, for every number, for every integer number you have, if we add n to it, we get an equivalent value. And just to show an example of that, if we have 1 modulo 9, let's keep adding 9 to that and verify, just experimentally, that that holds true. Well, 1 modulo 9 is just 1. 1 plus 9, well then we get 10. 10 modulo 9, that has a remainder of 1. Then we get to 19, which is a remainder of 1. It's 1 greater than a multiple of 9. Add another 9, and we're getting 28, which is also 1 greater than a multiple of 9. So the pattern continues, clearly. We would get 37, and then 46, and then 55, 64, 73, etc. So for whatever number we choose to start with, whatever integer we choose to start with, as long as we add n to it, we're getting an equivalent value at mod n. So that same principle applies, in fact, to negative integers. So if we start with negative 2, we can add 9 to that and get 7. So negative 2 is congruent to 7 modulo 9. That's how we would deal with that. But if it were more complicated, such as negative 14, well, we'd need to work with it perhaps a different way. Really, we can repeatedly add 9 to it, and we would find that negative 14, as you can see, is congruent to 4 modulo 9. And so the whole idea is finding the minimum difference between that number and the closest multiple of n that is below that number. So for negative 14, the closest multiple of 9 that is less than negative 14, you can think of it as being equal to negative 18. That's kind of our baseline multiple of 9. And so as compared to negative 18, negative 14 is 4 steps away. And so that's kind of another way of reasoning it out. So yeah, I just wanted to make that note.